transform this as port 1 V1. I can say this current is I1 now. This current, leaving current is I1, so entering current must be also I1. What are the current is leaving, the same current has to return. And this voltage I can call it as second port V2, and this current I can call it as I2, and this return current is what? I2. What are the current is leaving, the same current has to enter, isn't it? Now this one, at this one, how much this voltage is a V1 I can say, and how much this voltage here V1. Now this YA, this is ohm most given now, so that is admittance. So can I apply the nodal at this node 1 here, V1 node? Write the nodal equations now here. Entry current I1 is entry current, which is equal to, now this is leaving current now, how much it is a V1. If it is impedance we should write by, but it is admittance now, so into YA I can write plus, and this one V1 minus V2, yes, into what now here, YB. So now I can remodify this equation as what it is, a YA plus YB into V1 plus minus YB into V2 I can say. Now we know the one Y parameter equations of what? I1 is equal to Y11 V1 plus Y12 V2 now I can compare these two. From these two equation comparison I can write this Y11. What are the Y11 here from this? YA plus YB. Next Y12 is how much it is, a minus YB. Y12 is how much? Minus YB I can say. Right. Now the same analysis we are doing at the second port also. Second port I am applying the nodal here. Tell me, write the nodal equations now. What I can say here, this is I2 entry current, so this is V1 into YC, this current, and this current, so this voltage V2 now, sorry, this is V2. Next, what now, this volt current is what? V2 minus V1 into YB. So I can remodify these equations as what it is, a minus YB into V1 plus YB plus YC, YB plus YC into V2. Can I will write as like this? Check it now here. From this we know the second Y parameter equations. I2 is equal to Y21 V1 plus Y22 V2 I can say. Now I will compare these two equations now here. From this, by comparison of these two, I can write these equations as what? Y21, which is equal to what? Minus YB. Next, Y22, which is equal to what? YB plus YC, isn't it? So these are the Y matrix I can say. Finally, the Y matrix indicated as Y matrix as like this. The first one, Y11 is what? YA plus YB minus YB minus YB, and this is YB plus YC now. Right. Now if we observe carefully how this network here the network is like this. This is YA and this is YB and this is YC, isn't it? Now you tell me what is this Y11 is a, this is the Y11 now. This is nothing but what? Sum of these two, isn't it? And Y22 is what? Sum of these two, isn't it? Next, Y12 and Y21 is nothing but what now? This element, common element for these two. Right. Like this, we need to do. Here also we have one condition. What the condition is a, look at the units, more. That means admittance should be admittance only. The problem of this is we don't have any separate symbol for the resistor and inductor. We have only one symbol, resistor, and conductance. We have only one symbol. Admittance or impedance, we have only one symbol. For inductor we have separate, capacitor we have separate, but conductance and resistance or admittance or impedance we have the same symbol. We used to indicate like this. That is resistor, but we need to identify whether it is a resistance or conductance, impedance or admittance. According to the units only we need to identify. This is one of the very important thing. So this has been given so many times in the GATE exam. The students used to confuse here. So if they given a network like this, directly they can do without simplify, without looking at that units. Very careful here. Here what are the